Okay, let's start the webinar now. Okay. So, as you know, this webinar is on serverless apps in Azure. So, but before starting the presentation, I want to ask one question so that I can get more knowledge about your knowledge on serverless, and I can plan the things accordingly. So, poll you will see on your screen in 5 seconds, and please put your answers on the screen. So poll has started. I have kept time limit of 30 seconds. One zero. Okay. So I got your answers, and it looks like many of you okay have fair knowledge, and some of you have just heard the term serverless. So let's try to understand what is serverless first. So let me share my screen and start presentation. Okay. So the topics that we are going to cover in this webinar is first the introduction to serverless, then Azure functions, stream analytics, and Azure Synapse analytics resources that are part of Azure serverless categories. So let's start. Okay, we have already done poll. So let's start with what is serverless. Okay, serverless is the evolution of cloud platforms in the direction of pure cloud native code. Serverless brings developers closer to business logic while insulating them from infrastructure concerns. So you can say it's a pattern that doesn't imply no server, but rather less server. And serverless code is event driven. Code may be triggered by anything from traditional web request, HTTP request, to a timer or result of uploading a file. The infrastructure behind serverless allows for instant scale to meet elastic demands and offers micro billing to truly pay for what you use. Now let's understand the evolution of cloud platform, how it started from on-premises. So when we were on premises, the first service that was offered was infrastructure as a service, which is also called as IaaS. It includes virtualization of hardware via virtual machines. It takes away the responsibility of managing hardware and capital expenditure for innovative projects. However, you still have to manage the base operating system, then security patches, and software installations. So, as a next part of the evolution, platform as a service arrived, which is also called as PaaS. PaaS offers configured solutions that developers can plug into directly. It eliminates the need to manage the base host operating system, security patches, and in many cases, any third party dependencies as well. Again, however, the main disadvantage of PaaS traditionally has been vendor lock-in. For example, some PaaS providers only support ASP.NET, some support Node.js or other specific languages and platforms. So then arrived functions as a service, or server, we can call it as serverless. So this FaaS is a specialized container service. It is a specific implementation of FaaS called OpenFaaS that sits on top of containers to provide serverless capabilities. A serverless architecture provides clear separation between the code and its hosting environment. So as you can see in the table below, that we have compared all these cloud platforms with each other. And this table shows you the differences among the platforms. We will skip this table since we already discussed it and many of you know what it is. So you can go through the contents once we share the PPT presentation. But yeah, let's move on. So again, before moving on to the benefits and applications of serverless, I have another poll to get so that I can know in advance if you have faced certain scenarios. So let me start the poll. Yeah. So this poll, I am starting the poll. This poll is about if you have experienced inconsistent web responses with some web application, like it goes down during specific time of day, at afternoon or in the evening, likewise. Okay. So a lot of you guys have experienced these things. Okay. So that means there was sluggishness in deployed web services. Okay. Now let's start with benefits of serverless apps, and let's see if it can help us mitigate this issue or solve these problems. So the first benefit of serverless is micro billing. Most service providers bill based on serverless executions, enabling massive cost savings in certain scenarios. So this is a huge benefit for organizations. For example, it's common for web applications to host web API endpoints. In traditional bare metal, IaaS, or even PaaS implementations, the resources to host the APIs are paid for continuously. That means you pay to host the endpoints even when they are not being accessed or used. Also, often you will find one API is called more than others. So the entire system is scaled based on supporting the popular endpoints. So, client might decide not to scale because of the cost or budget issues. That can result in this sluggishness of web applications. Now, the benefit of serverless is it enables you to scale each endpoint independently and pay for usage. So, no costs are incurred when the APIs are not being called or accessed. And this can dramatically reduce ongoing cost to support the endpoints. The next one is high density. So, many instances of the same serverless code can run on the same host compared to containers or virtual machines. And that provides high density to us when we are using Azure functions or logic apps. The third advantage is instant scaling. So serverless can scale to match workloads automatically and quickly. And together combined, these all features or benefits result in faster response times, reducing slowness. And last but not less important is faster time to market. So developers actually focus on code and deploy directly to the serverless platform. So components can be released independently of each other. And this is very big benefit for the big organizations. Now let's look at the applications, the business scenarios or use cases, as we say. So where can we use these serverless apps? They can be used as extensions for web APIs in specific use cases. For example, applications that rely heavily on microservices may implement all microservices using serverless. Then we can use them to implement IoT reliable edge relay. Reliable edge relay is a micro pattern that demonstrates a reliable streaming data ingestion from the IoT edge. Then we can use them to develop function that exposes different APIs. For example, GraphQL API that we have implemented in our organization. Then we can use them to implement serverless mobile APIs. And apart from these extensions, we can also use them for file processing and validations whenever the files are being uploaded on storage services or being downloaded to on-premises storage systems. We can use them to implement reminders, notifications, and serverless messaging among your different applications. Then we can also use them for running background backup tasks and for big data or data streams processing. These are all the different use cases that I have come across so far, but there can be more. Now let's look at the architecture of serverless. So starting in bottom up direction, the first layer is container or PaaS. So serverless hosts often use an existing container based or PaaS layer to manage the serverless instances. For example, Azure Functions is based on Azure App Service. For Windows-based functions, the host runs as PaaS and scales out the .NET runtime. Whereas for Linux-based functions, the host leverages containers. The next layer comes is the web job score. It provides an execution context for the function. It simplifies the task of adding background processing to your function app. The next one is language runtime. Language runtime runs actual scripts. It executes libraries and hosts the framework for the target language. For example, Node.js is used to run JavaScript functions, and .NET framework is used to run C# functions. And on top of that sits your client's function code and client's function configuration. So this is how the serverless architecture is. Now let's discuss about the resources that are available in Azure for serverless applications. Let's start with the easiest and very widely used or integrated into the Azure applications resource, which is Event Grid. So Event Grid, Azure Event Grid provides a serverless infrastructure for event-based applications. You can publish to Event Grid from any source and consume messages from any platform. Event Grid also has built-in support for events from various Azure resources to streamline integration with your applications. For example, you can subscribe to blob storage events to notify your on-premises or cloud application when a file is uploaded. Event Grid was built reliably to handle massive scale. So you get the benefits of publishing and subscribing to message without overhead of setting up the necessary infrastructure. So out of the box, you are getting the publish subscriber pattern implemented in your cloud platform itself. Now, the major features of Event Grid include fully managed event routing, near real-time event delivery at scale, and broad coverage both inside and outside of Azure. So we will look into the practical example of Event Grid when we are discussing the demo of Azure Functions. So let's move on to the next resource, which is Azure Functions. So Azure Functions provides a serverless compute experience. A function is invoked by a trigger, for example, HTTP trigger or a timer trigger, and executes a block of code or business logic. And as of today, Azure supports writing functions in 7 different languages, namely C#, JavaScript, F#, Java, Python, TypeScript, and PowerShell. Functions are backed by an app service plan, but for true serverless approach, function apps can use the consumption plan. The consumption plan will scale the backend automatically based on the load it receives. Another hosting option for function apps is the premium plan. So if you are facing the challenge of startup performance for any instance of the function, then you can use this plan, because this plan provides an always-on instance to avoid cold start or cold boots. It also supports advanced features like VNet connectivity. Let's understand triggers and bindings. So triggers and bindings make functions easy to work with. Now to show the triggers and bindings, how they work in function, I am going to switch to Visual Studio. So okay, so triggers in functions are what cause a function so the triggers are what cause a function to run. Functions are invoked by a trigger, and it can one function can have exactly one trigger. So now if you are using Visual Studio 2019 or above, you get the functions template built in. Otherwise, you can download the template in your respective Visual Studio versions. So let's say, what are the triggers? So you are able to see the screen. Okay. Okay. So once you select the Azure functions from template and you go ahead to create the function, then here you can see numerous triggers that are available for you. For example, you have HTTP trigger for a function that can be invoked via web request. You have a service bus queue trigger to listen to the messages from queue. You have timer trigger to invoke the function at specific intervals. Then you have a blob trigger. You have SQL input binding for binding for your on-premises SQL stored procedures. Then you have event grid trigger, IoT hub trigger, event hub trigger, lot of options you have. That way you can select the triggers. Another point is the bindings. Okay, so bindings provide a declarative way to connect data to your code. They can be passed as input or output. Bindings remove the overhead of manually creating the database or file system connections. So you don't have to write a code to manually have the connection to your service bus or to your Azure data lake. All of the information needed for bindings is contained in special functions.json file when you are deploying a function package. So let me show you the bindings. So here, this is a simple HTTP trigger. Now here you can see you are already provided a HTTP request, and all the data that you need from a HTTP trigger you can get inside this object. For example, body, query string, then you can get the remote IP address, headers, all the things. Similarly, if you are listening to the Azure event grid, and if you have event grid trigger, then you get the event grid binding directly, where you can get access to data such as event type, time of event, name of the topic, subject, version of this event, metadata, all those things. These are the bindings that are automatically provided when you are writing a function. Okay. Now let's have a demo of how the Azure functions work. So I won't go ahead and create the Azure function because it is a very straightforward way to create Azure function. So there is another way actually that I want to show you to deploy the functions. What you can do is directly inside from Visual Studio or Visual Studio Code, which is open source editor, you can go ahead and publish your function app onto Azure directly. So here you just have to select the platform, the cloud service provider that you want to use. I'm using Azure. I'm using Windows functions because I'm using C# right now. And once you do that, then you can get the functions that are available on your portal, your subscription, or you can create a new function. Once you click on finish, you can publish this function directly. The other advantage of Azure functions using the editor is Visual Studio allows you to debug, test and develop the code locally by using Azure Storage Emulator. So I can directly invoke my function, Azure function, here on the localhost as if it was running on Azure. So as you can see, it is starting the storage simulator. And here my function is up and running locally so that I can test my function. Simulator started. Okay. So now I can invoke this function by using this HTTP trigger, HTTP request. So let me go to first one to send this request. So yeah, first let me tell you what this function does. This function takes an XML file into HTTP request and converts it to the JSON file. Once it is converted, it dumps this file onto Azure Data Lake. So now here you can see I am passing XML body into the in this HTTP request. Once I click on send, you can see the HTTP trigger function processed the request. New instance of function was created. Now if we go on to Azure Data Lake and if we see, so here you can see at 6:51 it has converted XML to JSON and dumped it on the blob storage. And while converting to JSON, it is also adding the country by recognizing the IP address and using third-party APIs to recognize IP address. So I have my function. I have also added the email service. so that I can get the email notification that function was successful. Yeah, this was one scenario, and I also have the same functionality we can achieve with different triggers. For example, if you see here, I have service bus trigger function which listens to the queue, this queue on the service bus. So you have to provide service bus connection inside a configuration, functions code configuration, and then same functionality can be executed with service bus triggers. So this is how the function works. We will look into it more as and when we go forward. Okay, the next next subtopic I would say is the durable functions. So there are some challenges in normal functions. Like there are scenarios where you want to maintain the state of a function during its execution. So in this case, since normal functions are stateless by default, we will have to use Azure storage or queues to manually save and retrieve the state. And it can involve a lot of complexity, like making your function available by using premium plan or tweaking the consumption plan. But instead, Azure provides a better feature in such cases. It is called durable functions. So what this durable function is, it is an extension of Azure functions that lets you write stateful functions in a serverless compute environment. So it gets defined into two different parts. One is orchestrator functions, which defines the stateful workflow, and other is stateful entities, which are called activity functions. And in this Azure functions programming model, how it works is, so let's consider FO as an orchestrator function, and we are going to see the chaining approach in the durable functions. So here if you see, when the chaining starts with the master function, the orchestrator function, instead of calling next activity function directly, it puts the message on queue and corresponding activity function is triggered based on the message. Then orchestrator function goes to sleep until it gets the return result. Framework keeps this information about execution of functions on execution history table. This table is stored on underlying function storage resource. We don't have to do anything manually here. Now, once activity function is finished, it puts another message on queue, which then wakes up the orchestrator function. Orchestrator then retrieves information from execution table, detect its current state, and decides which activity function to call next. This is how you can make use of durable functions for different complicated scenarios. Okay, now moving on, let's discuss Azure Logic Apps, the next resource under serverless category. Azure Logic Apps provides a serverless engine to build automated workflows to integrate apps and data between cloud services and on-premises systems. You build workflows using a visual designer. So Azure portal provides a declarative approach where you can use drag and drop elements to have a visual designer. And you can trigger workflows based on events or timers and leverage connectors to integrate applications and facilitate business-to-business communication. You can also orchestrate on-premises workflows with the on-premises gateway. For example, you can use the Logic app to trigger an on-premises SQL stored procedure in response to cloud-based event or conditional logic in your workflow. So these are a few of the resources and activities using which Logic apps can orchestrate workflows today. They are very easy to set up and configure. We will look at it in the demo section. Now Logic app triggers. Again, here similar to Azure functions, we have triggers to invoke a Logic app. So similar to the functions, we have service bus trigger, timer trigger, HTTP trigger. Apart from that, we also have Twitter connector, which can listen to a tweet whenever it is posted and notify. We have Outlook, OneDrive, as well as FTP server triggers here. Okay, now let's look at the example. So this is a Logic app that I have created. Once you create the Logic app, you get the Logic app designer built into the Azure portal's blade. So I go here in the designer and I start designing my logic app. So the flow is you have to define the connector or the event on which you want to, or the trigger you want to invoke the logic app. Then you define a condition, if whether if that condition is met or not, and then based on the return result of the condition like true or false, you can invoke an action. So here, for example, what I have done is, as I already told you, Azure Event Grid is built into the Azure portal. It is integrated into every Azure resource. So we are going to make use of Azure Event Grid and listen to storage accounts events. So right now we are listening to two events, blob created and blob deleted events. So whenever these events will occur, Event Grid will deliver these events to my logic apps. And then here I have specified the data lake storage account that I want to listen to. Once I receive the event, I specify the condition that if the event type is equal to blob created, then only do my action. So here on this, when the condition is true, I am sending an email to my organization or to my IT support group. So let's say now, as of now, I am sending this email to myself, but let's see how this works. So I am going to put a file on the Azure Data Lake storage. Okay, as soon as it is uploaded, you can see in the activity of Azure Logic Apps that at 6:58 it ran the Logic app. Here it is. So I received the email notification via Azure Logic Apps. So yeah, this is how it works. Let's go back to slide. We have seen Logic App example. Now let's move on to the next section. Here I want to share a very real life scenario that I have implemented using all the three resources, that is Azure Functions, Azure Event Grid, and Azure Logic Apps. So let me tell you the scenario first. What was the requirement? So in one of the projects that I worked on, it was a web application and it had 4 environments and 4 different geographical regions in each environment to comply with GDPR. So regions were dev, QA, stage and prod. And then there were 4 SQL servers where each SQL server was talking with approximately 8 web applications. Now the requirement was for security and sharing reasons. We needed to keep SQL credentials in Azure Key Vault as well as SQL connection strings for our web applications in the Azure Key Vault, and automate its expiry and creation by applying the new credentials every X number of days. These new connections should also get updated in SQL servers as well as web app configurations. So in total, 32 web apps and 4 SQL servers needed to be updated using this secret modification strategy. So if considering the human error, possible human errors and probability of unavailability of resources, we decided to automate this process using Azure Serverless apps. So let's see how it goes. The first resource in picture is Azure Key Vault, where we store password and connection string for the web applications. So first time we manually set the expiry date. As soon as the expiry event occurs for a password, SQL password, it sends expiry event to Event Grid. Event Grid then delivers this event to my .NET function, my C# function. This C# function is kind of a central logic, a central business logic, which performs all the other activities. So once it receives the event, what it does is it creates a new SQL password, new SQL connection string, and then it updates this password. It updates the SQL server with new password. It again verifies whether the password updation was successful on SQL server. If not, then it rolls back the entire changes. Otherwise, if it is successful, then the function sends newly created credentials and connection strings back to the key vault. Once the key vault is updated, it then invokes another function, which is a PowerShell function. And I am sending the connection strings to the PowerShell function. The responsibility of PowerShell function is to update web app configurations and restart the web applications so that the connection gets established with the newly updated SQL servers. Once the connection strings are updated and the whole process is finished, then I am invoking the logic app to send me a message that the process is successful. So let me show you on Azure. So here what I have done is for the purpose of saving time, I have already run this automation and will show you the results and telemetry. So if you see here at 6:27, my Azure Key Vault sent the expiry event into the Azure event grid. Now if you see here, I have already linked my this .NET function to the event grid that is used by Azure Key Vault, and that's how my .NET function received this event through the Key Vault. Now if we go to the Azure .NET function, this is the .NET function and this is a live telemetry. So here if you see, it received the event. Here the secret name was this for the dev environment. It started creating new password, got list of SQL servers, then it updated all the SQL servers. It updated the Key Vault here, and then here .NET function called my PowerShell function, and the process was finished. Now going to PowerShell function, if you see here, it was get called. So there are different sub functions that you can different blocks of code that you can have under single function when you are using PowerShell. So let me show you that. So this is how the PowerShell function got executed and it returned the data. So if we go to the function section here, you can see different functions. So here, if you go to get SQL server, you will see the code I have written. For getting the SQL servers. So similar to that, there are other functions in my PowerShell function resource. Now after that, I will check if my web app works correctly with the new connection string. Yes. Okay, so everything was set. If you see here in the configuration, so what happens here is it fetches the new value from SQL Key Vault secret without exposing the confidential data. So this is how we can make use of Azure serverless apps. Okay, moving onwards. So the next resource we are going to talk about is Azure Stream Analytics. It is a real-time analytics and complex event processing engine that is designed to analyze and process high volumes of fast streaming data from multiple sources simultaneously. Sources include IoT devices, sensors, clickstreams, social media feeds, and so on. It is available. Stream Analytics is available on Azure IoT Edge runtime, enabling to process data on IoT devices. So let's look at the benefits of Azure Stream Analytics. First one is ease of getting started. In Azure ecosystem, it only takes a few clicks to connect to multiple sources and sinks, creating an end-to-end pipeline entirely. Then comes developer productivity. So it provides a simple SQL-based query language to analyze and process the data in motion. You can use SQL, C# or JavaScript, whatever suits you. Then comes the total cost of ownership. So the thing is, there are no upfront costs involved in the stream analytics job. You only pay for the streaming units that you consume. And fourth one is the intelligent edge. So most live data streams become useless just few seconds after it's generated, right? So in such cases, processing data closer to the point of generation is becoming more and more critical. Azure Stream Analytics enables you to deploy real-time analytics closer to IoT devices, enabling you to have a useful data. Next one is reliability and security. So Stream Analytics guarantees exactly once per event processing, and it also supports encryption along with TLS 1.2. Let's look at the different application and use cases. So as you can see on screen, we can use them to analyze real-time telemetry, web logs, geospatial analytics, remote monitoring, or in real-time analytics on point of sale data for inventory control and anomaly detection. Okay, so next is, let's see now how exactly it works. So Stream Analytics consists of three parts: input, query, and output. Okay, so in input part, it ingests data from Azure Event Hubs, including events from Apache Kafka, Azure IoT Hub, Azure Blob Storage, these kind of resources. Then in the query, which is based on SQL, it can be used to easily filter, sort, aggregate, and join streaming data over a period of time. You can also extend this SQL language with JavaScript and C# user-defined functions. Okay, so each job has in the output part, uh, each job can have one or more outputs. So for example, you can send data to Azure function service bus to trigger custom workflows, or you can send data to Power BI dashboard for real-time dashboarding. You can store data in Azure storage services like Azure Data Lake and all. So now let's look at the example. Okay, so to implement this Stream Analytics job, I need four resources. The resources needed are, first is obviously the IoT hub, on which the my IoT device will send events or messages. Then comes the storage, Azure storage account, where I will dump the data, filtered or aggregated data. Then I have my Azure Stream Analytics job. So this is the Azure resource, Stream Analytics job, where you can configure everything for real-time analytics. And then last but not least is my IoT device. So I am using this Raspberry Pi web simulator to simulate the IoT device. So here what I do is I have provided the connection string of my IoT hub so that it can send event to the hub directly. Now let's see how we can configure this from Visual Studio itself. So once I create the Azure, again here in Visual Studio, you get the ready-made template for creating Azure Stream Analytics resource, whether it is SQL, C# or JavaScript, anything. Now once you create a Stream Analytics project, first thing is you configured inputs. So here I have attached IoT Hub as an input, and all the other settings I have kept them to default. In the output section, I have linked my Azure storage account, which is stream device data. And again, other settings I have kept to default. And here is the query part. So if you see, my query is only if the temperature property that I receive from the message, it is greater than 27, then log this data or show the data in my data lake storage account. So now let's start the IoT device. Okay. Now if you see, it has started sending the data along with temperature. We should have temperature greater than 27. Now let's see. Refresh. Output. Okay. Okay, so let me quickly. So one thing you can do if you feel any issues during the IoT device transmission, so you can get the connection string from here. directly put connection string and run it. We have not received temperature greater than 26 yet. Okay, we have. There might be some technical issues. But yeah, let's move on. So in the end, as a result, you will see the JSON file which contains all the messages indicating the temperature has exceeded here. Okay, so moving on. Okay, the next and the last resource that we are going to discuss today as the first part of serverless analytics is the Azure Synapse Analytics. It is the Synapse Analytics is a limitless analytics service that brings together data integration, enterprise data warehousing, and big data analytics. It gives you the freedom to query data on your terms using either serverless or dedicated options at scale. It provides unified experience to ingest, explore, prepare, transform, manage, and serve the data for immediate business analysis, business intelligence, and machine learning needs. Then there are different key capabilities that Azure Synapse provides when it comes to big data processing and data ETL pipelines. Now I have for example, I have the demo ready for you. So I will just show you the Azure Synapse Studio on the Azure portal and will explain you how this Synapse cycle works. So due to lack of time, we have to move quickly. Okay. Okay. So once you create Azure Synapse Workspace, what you get is a visual editor in the web browser itself, which is called Synapse Studio. So this is a Synapse Studio where you can this also integrates the data factory, Azure Data Factory inside it. So you don't have to go to Azure portal for different activities. For example, now what I want to do is whenever the JSON file is uploaded on Azure Data Lake, I want to do the processing, ETL processing of that file. So this is, for example, in this Azure Studio, what I have done is I have linked my Azure Data Lake storage here. Now to perform the ETL, I have created a notebook resource. So here you can do the filtering or processing on data using different resources using SQL or KQL script. So as of now, I have used notebook resource, and in notebook we have different languages available. As of now, we have Python, Scala, C#, and Spark SQL. So I am using Python here, PySpark, to process my data, my JSON file. And in the integrate, you can create actual pipeline where you can define different resources. So for example, if I create a new pipeline here, I will put my notebook here. I will apply what notebook it is. I'm also going to specify the Spark engine that I'm going to use to perform the processing on this big data. Then I can use yes. Here, what I'm going to do is what I have done is I have used Azure function to back up the files whenever I receive the file in the data lake, so that once the processing is done, if any error is there or if any inconsistency is there in data, then I can check it back, verify it back with the original file. So this is how we can create the resources in Azure Synapse. And let me quickly show you pipeline runs and the data, how it creates a table that I will show you. But before it the log comes, let me show you how this functionality works. So first, when the file is received, I am backing up that file using Azure function. Then I am calling the PySpark script using notebook. What Python does is it will create a Parquet file. It will process the Parquet file and create the SQL table. This SQL table then I am putting into the SQL data warehouse using SQL stored procedure. If something goes wrong, then I am using logic app to notify about this failure to our IT support group. And if everything goes on, then I have provided the next conditions on which some other activities gets executed. So yes, so this was about the Azure Synapse Analytics in short. So we still have 10 minutes left. So let's. I have one more call. So I wanted to know about how useful you find this webinar, and if not, what can be improved. So let me start my poll. Okay, the poll is started. Okay. Okay. So it's kind of a 50-50 response. So some of you are satisfied with the presentation, where some of you would like to know more about this. So yeah, if you like to know more about how we can help in implementing this serverless approach in your environment, then you can reach out to our team. You can reach out to Devesh Agarwal. We have given the contact in the webinar template itself. And the next but important section is questions. So if you guys have any questions, let's take them here. So let's wait for 30-40 seconds, or let's wait for a minute if someone has any questions. Till then I'll drink some water. Okay, I see one question so far. Okay, let me start with this question. So the question is how to handle jobs that run beyond default time limit. Okay, so yeah, as you understood correctly, so the Azure functions the comes with a default time limit, the normal functions, with maximum up to 10 or 15 minutes as of today. So, but yeah, you have two approaches actually. If you want to overcome the time limit, if in your scenarios, first is you can use the premium plan. Premium plan provides always on instance, so that one instance, at least one instance, will always be on, and your processing will continue for days or even months. And the other option is you can use durable functions. So durable functions can be run on consumption plan as well. And the advantage is only when it is needed to wake up the orchestrator function, it will do so. Otherwise, all the other activity functions will get called in chain whenever one processing finishes and the user goes to the next level of your complicated logic. Okay, so that is one way. Okay, next question is okay. So it says I have a web application. If I have a web application which is deployed on a server on premises, okay, how do I take steps to go serverless? Okay, so yes, since you have on-premises application, so first thing, if not already done, is that you will need to break it down to individual loosely coupled modules. So as we earlier mentioned, you can make use of microservices architecture to decouple your functionalities into different endpoints. For example, login functionality will be different. Then feedback functionality can be broken out from the main application logic, and that functionality can be put on to the Azure functions as a serverless cloud resource. So this way you can do, but yeah, definitely you can make use of microservices architecture and then use the serverless apps effectively. Okay. Okay, so third question is what are the cost benefits that my organization gain? Okay, so as I already told you, so main advantage is budget. So you get billed only when your web endpoints are getting accessed by your customers. So if they are not being getting accessed, if you have, let's say, 27 endpoints and only 7 endpoints are frequently accessed, so for other 20 endpoints, the Azure function instance will scale down or will go to sleep unless and until it is invoked by external trigger. So in that case, all the cost for these 20 endpoints get saved. And also there are, yeah, and one of the main advantage. So what happens in platform as a service like app service, you have to manually scale down or scale up the resources. But here in Azure functions, you don't have to do that. So the function platform automatically takes care of creating new instances and scaling them up whenever the load increases, or scaling them down when there is no activity going on. So that is also automatically taken care of, and it automatically reduces in cost savings. Okay, I think these were the all the questions. Okay, guys, so I think we have covered it, and we are in time. So yes, thank you for your time. See you.